Okay. Hello, everyone. My name is Arijit Bhomik. I have given the CSCA exam in both January and December, and I have a good understanding of what comes in the exam and what doesn't. And I also have a really respectable score of an 18 math and 18 physics. I'm applying actually this year on China. Wish me luck. But today I'm going to teach you the chapter called set theory. This is a very important chapter. Even though there isn't much questions from this chapter specifically, the concept of this chapter actually will be useful on functions and will be useful on inequalities as well. So you really need to get the notations of this chapter down. And if you want the slides of this of the slides basically, so you will have to join our WhatsApp group, and you can message any one of our admins, and we will provide you with the slides for absolutely free. Okay, so now let's start this lecture. Also, this is, by the way, this is a paid course, and we are giving this lecture for completely free, but the later chapters will probably be paid. Okay, so let's start. What is a set? So set is a well-defined collection of distinct objects. Okay, what does that mean? So it can be something, it has to be very well defined. What does well defined mean? How well does it have to be defined? For example, let's say you just said, okay, set can be like 1 2 3 wait, set of numbers, let's say 1 2 3 4 blah blah blah. But is this really a set? If it were to say something like um this guy a the let's say Rohit, and then say Kamal, and let's say um Arijit. Okay, I cannot come up with more names. So Rohit, Kamal, and Arijit, they have they each have 1 2 and 3 apples. That way this will be a set. So it has to be very well defined, and it has to be collection of distinct objects. It cannot be two different things. It cannot be 1 apple 2 oranges. It has to be same things. Okay, so that is what we call a set. Is that clear? Anyways, so well defined means there's no ambiguity about whether an object belongs to the set. Okay, so that's pretty self-explanatory. So I'm just going to move on to the notation. So what does notation mean? Notation means how do we write the set? Okay, so the sets themselves are denoted by capital letters. So we can say a set is blah 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 and this. Okay, so this set, the name of the set, is going to be denoted with a capital letter, and the elements are elements in between the sets, let's say x y z whatever, these will be denoted by a lowercase letter. Okay, now let's move on to the next slide. Methods of representation. Raster method. So we can denote set in two different ways. Okay, we can do it this way and this way, right? So this way is called raster method or tabular form. This way is called set builder notation. Okay, listing elements within curly braces separated by commas. So these they are calling, this is the curly braces. We can also call it the second bracket. And 1 second. Okay, sorry for that. So these are called self builder notations. So how can we go from one to another, or how can we say that they are the both same thing, or we can basically, how do we write any of these? So this is pretty self-explanatory. Just write down all of the elements in the set. Okay, but this is a bit different. So what it says is a is equals to x, such as, this means such as x is a natural number less than 6. So this has to be a natural number. What does natural number means? Natural number mean 1, 2, 3, 4, 5, blah 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 blah. Okay, it goes to infinity. It cannot be 1.5, it cannot be 0, it cannot be a negative number. Okay, these cannot be a natural number, it has to be integer. Okay, so what does this mean? X is a natural number less than 6. What are the natural number less than 6? Is 1, 2, 3, 4 and 5. Okay, so these are the natural number which are less than 6. So these set and this set means the same thing. Are we clear? We are probably are. Okay, so let's move on to the next slide. So we have a CSCA question right here. So which of the following is the set builder notation for A? Okay, so it's asking us which are the following which of the following is a set builder notation. Okay, so we are given a set. This is 1. A is I cannot draw a second bracket. I'm going to be very wonky when I'm drawing a second bracket, so please forgive me. Okay, so we can say this is the set. So is it X? Okay, so we can see the options right here. So the option is X is a prime number. None of these is not a prime number. This is not a prime number. This is not a prime number. This is not a prime number. Okay, so we cannot say A is true. So what is X square? X belongs to Z, and 1 is bigger than 1 or equal, or less than 5 or equal. So this is the right answer. Okay, first of all, this is the right answer, but I'm gonna get how we got it in a second. But let's look at the option number C. X is an odd number. There are even numbers here, so it cannot be all odd number. X is a multiple of 2. It's not a multiple of 2. Okay, because we have 1 here, we have 9 here, we have 25 here. Okay, these are odd numbers. That means they are not a multiple of 2. Okay, now how do we get this? So it says A set is X square such as X belong to Z. Z means all real number. Okay, all rational number. And comma 1 bigger than or equal to X, and bigger than less than equals to 5. So what does that mean? We can say something like this. Look, 1, 2 squared, 3 squared, 4 squared, 5 squared, right? We can say this. So we can see this is a function of X squared, right? So X power 0 is equals to 1, X power X square, X cube, X square, X square, X square, and X power 1. Okay, so it's probably X square as well. We can just say this. This is also a whole square, because 1 square is 1 square, right? So this is, we can see X is increasing by 1 increments, and it is through 1 to 5, right? It's through 1 to 5 and it's increasing by 1 increment. So we can say this is true. By the way, Z is all rational numbers between I think it's included negative. It's included negative, and it's also included 0, I think. Maybe not. I actually have to look it up. Let me look it up. And okay, so I was right. Z can be any integer number. So it can be negative, it can be 0, it can be 1, but it 1, 2, 3, whatever. It can go from minus infinity to plus infinity, but it has to be an integer. What is an integer? It cannot be 1.5, 3.2, pi. Okay, so it cannot be a point dot something like that. Okay, something point something something. It cannot have a point in there. So that's an integer, and Z is an integer, and it can be negative, it can be 0, it can be everything but any point numbers, right? So it has to be distinct numbers, and we can see these are distinct numbers because 1, 2, 3, 4, 5, and they're whole square. That's why there's a square here, and we can see that it's through 1 to 5, 1 to 5. So this is the correct answer. Okay, let's move on to the next slide. Membership notation. Okay, So this means is an element to or belongs to. This means is not an element of or does not belong to. So A belongs to this. Okay, so let's say we have a set of A equals to 2, 2, 3, 4, and we are saying 4 belongs to A. We can this is true. We can also say 5 does not belong to A. Okay, so these are the things. Okay, element to set, use this to connect element to set. So when these things are elements, these are sets, right? So when we are connecting elements to set, we use these things. Okay, we use belongs to. Got it? Use this when we are connecting a set to set. Okay, use this. So let's say we have this 2 comma 4 comma 5, right? So we can say 2 comma 4, this set, there's a set b is another set which is called 2 comma 5. Okay, these are the elements that are in set A. So we can say B belongs to, not really belongs to, we have to, as we are using set to set, we have to say this sign right here to connect A. Okay, so this is the sign we use for sets. This is the sign that we use for elements when we are trying to connect an element to set. Now let's look at this question. Let A and phi denote the empty set. Okay, which of the statement is correct? Okay, C belongs to A. Okay, so as we can see, they're saying belongs to, but this is a set. That means this is wrong. 9 belongs to A. This is probably correct. 6, this is used for sets, not for elements. So this is not correct. This is also a set. This is also a set. This is what do we call it? This is an empty set. Empty set. Okay, what does empty set mean? It means a set that has nothing in it. That's what is an empty set. So this is also a set, and they're using belongs to. This is not correct. This is an element. They're using the notation for sets, so this is not correct. It's a set using belongs to, not correct. Using an element using belongs to, this is correct. Okay, so let's look at this question. Finite versus infinite series. Finite set, infinite set. So basically one of them is not infinity. This just goes on forever. This doesn't go on forever. It says this has exactly 7 elements. So X is a day of the week. It is a day of the week. So there's only 7 possible things that can be in this set. There can be infinity possible things in here. So this is a set for normal numbers. So it goes from 1 to infinity. So we can see there's the distinct difference between finite and infinite set. So let's move on to the next slide. The universal set definition: a set that contains all the elements under consideration for a specific problem. A set that contains all the elements under consideration for a specific problem. Okay, so basically is the summation of all the sets. Okay, is the summation of all the sets. Okay, so there are a couple of sets. Let's say A, B, C, A, B, C, right? So if we take all the elements of A, B, and C, add them up, we can say the universal set for these 3 elements are going to be all of the elements together. Okay, so we can this is usually denoted by U or E. Visual representation in Venn diagrams, the universal set is represented as rectangle. So what is a Venn diagram? Venn diagram means, let's say this is a circle, this is another circle. Okay, so let's say this is first circle is set A, second circle is set B. So let's say there are a couple elements, let's say 1, 4, 9 in set A, and there's 4, 5, 6 in set B. So you can see in there is an intersection between they both have as 4 in their set, and if we add a rectangle here, if I can add a rectangle here, this is a universal set which includes all of the elements. So that's how we notate a universal set for these kind of situations. Now let's look at this empty set. So what does empty set mean? I have already explained. A set that has nothing in it is called an empty set. An empty set is a subset for every set. Okay, empty set is a subset for every set. Every set has an empty set in it. Okay, what does that even fucking, oh sorry, my bad, what does that even mean? So let's say in an empty set, no, in a set, let's say a equals to, what does subsets actually mean? So a, b, I have to say a, b, c. So let's say this is a set. So what are the subsets for this set? The subsets for this set would be, first of all, we will have a, and okay, I'm just gonna draw just a normal bracket instead of these because they are annoying. So I'm sorry, they just pretend like they're second brackets. Okay, the second subset will be b, the third subset will be c, the fourth subset will be a comma b comma c. So the whole thing, the actual thing, will be also a subset for itself, and it will also be an empty there will also be an empty subset for this set. Okay, so this empty set will be a subset for all set. Okay, now let's look at this thing. Which statement is always true regarding empty set? So empty set will always belong to a set. This is just true. Okay, this will also be subset icon, not belongs to icon, again, because empty set is a set, not an element. A belongs to an empty set, this is never going to be true. Not always going to be true. It can be true if A is also an empty set, then maybe it might be true, but A doesn't necessarily have to be an empty set. And empty set does not carry a 0, it has nothing in it. Does not have a 0, it has nothing in it. So this is the right answer. Okay, let's look at the next slide, and we are talking about subsets. I already explained what subsets are. I'm going to explain it again. So basically, let's look at this. Set A is a subset of set B if every element of set A is also an element of B mathematical segment. Okay, so if set A is a subset of set B, if every element of A is also an element of B. So this is only true if this is true. Okay, so if every element of A belongs to B, then A can be called a subset of B. Is that clear? I think that's pretty clear. So mathematical statement would be like this: A is a subset of B. That means X such as X belongs to A and X belongs to B. Okay, so equality of sets: if two sets are equal, A equals to B, A can be called a subset of B, B can be called a subset of A. That is pretty straightforward. I can explain it to you by giving you an example. Okay, I'm just gonna do that. So let's say A and B are equal set. Let's say they both have 2, 4, 2, 4. Let's say that, and if they are equal, we all know they have a subset of themselves. I just explained. These are the subsets, right? Subsets, sets, right? These are the subsets, and we can say that these subsets are actually equal to them, right? That's why we can say A is a subset. A is a subset of B because the subset of A is this. So A is a subset of B. B is a subset of A. So that's how we can say this. Now let's move on to the next slide, and we can see we're talking about proper subsets. What does a proper subset mean? this means A means every element of A is in B. Okay, so every element of A is in B. In order to be a proper subset, it needs to meet these two conditions. First condition is every element of A has to be in B. Every element of A has to be in B. And if A is not equal to B, B contains at least one element not in A. Okay, so it has to be B contains at least one element not in B. What does that mean? That means, let's say B is 2, 4, 5, right? This is a by the way, this is the symbol for proper subset, and this is the symbol for subset. Okay, one of them is like this, one of them like this. This is the proper one, proper. This is just subset. Okay, this is the proper one, this is just subset. So let's say we have this set of 2, 4, 5. By the way, there will be second brackets here. I'm just putting first bracket for the convenience. Okay, so let's say there's another set called A and it has 2, 5. Okay, so this will obviously be a subset to B, and B contains at least one element that is not in A. So that means A cannot be equal to B. So if A and B are equal, they cannot be proper subsets to each other. They can be a subset, but they cannot be a proper subset. Okay, so let's move on to the next slide. We have some questions here. If sets A, B, then what? So we can already see there's one element that is not in A, so we can just say A is a proper subset. A is a proper subset of B, right? A is a proper subset of B. So they did not give, I think this equal to sign will be missing here. Wait, let me make sure of it. I'm not just spewing nonsense. Let me pause. Okay, so I was right. So for proper subset, it has to be this. This has to be the sign for proper subsets, and for normal subset, it has to be this. Okay, for normal subset this, proper subset this. But they have made a mistake here and they have put the sign for just subset here instead of proper subset. So this is technically wrong, but in this case this is right. Okay, so let's learn about power sets. So power sets are what are power sets? The set, let's say we have a set of A, B. Okay, so what are the subsets for this thing? What are the subsets for this thing? The subsets will be, okay, so the subsets will be not proper subsets, the subsets A, B, it will be A, it will be B, it will be nothing, empty set, right? So these will be the subsets for the set A, right? Then the power set of this set A will be the set that contains all the subsets of the original set. So these things you can see are the subsets of this set right here, but they're put together in a set. So if we're asked to get the power set of a certain set, and then we will just figure out the subsets for that specific set, and then we will put that subsets together in another set, and we will call it a power set. That is what we call a power set. Okay, and now we can see they are wanting the power set of A, so it is going to be this one, right? This one. So let's move on to the next slide, and we can see cardinality formulas, number of elements. So if you're trying to figure out the amount of total subsets that is possible, right? So let's say n of a, right? What does n of a mean? It means how many elements does this set have. Number of elements counts the elements in set A, total subsets. If number of the elements is m, then the total amount of subsets will be 2 power m. So I actually like to call it just n, right? Because n means number is just a lot more simpler for me. You guys can call it m. It's just your choice, just a personal thing. Okay, so let's say set A has, I'm just gonna draw first brackets again, 2 comma 4 comma 5. Let's say it has 3 elements, right? 3 elements. That means the amount of subsets will be 2q 8. So we'll, if you are trying to figure out the amount of subsets that are in this set, it will be 8 subsets. So we can just say 2, 4, that's 1, that's 1, 5, that's 1. We can say 2 comma 4, that's 1. We can say 2 comma 5, that's 1. We can say 5 comma 4, that's another. We can also say, wait, we can also say 2 comma 4 comma 5. We can also say empty set, right? Empty set. So 1 2 3 4 5 6 7 8. We can see there's 8, and that's what we got in the formula. We just put amount of total elements to the power of 2. Okay, and if we're trying to figure out the proper subset, is just do this and then take 1 out. 2 power n, take 1 out. Okay, because we're just taking this subset out, because it cannot be equal, a proper subset cannot be equal to the original set. Okay, simple stuff. So let's look at some past papers. A set has 4 elements. How many proper subsets does it have? How many proper subsets does it have? A set has 4 elements. How many proper subsets? Proper mentions, it has mentioned proper, so it's going to be 2 power 4 minus 1. 2 power 4 is 16, minus 1 is 15. That's correct. Let's go. So union of sets AUB, right? So let's say AUB. Okay, so what does this mean? Okay, I'm just going to be back. I'm just going to go to the washroom. Hello, I'm back. Thank you for being patient, everyone. Okay, so what does union of set actually mean, right? So let's say we have 2 sets. We have a set A, we have a set B, and the set A is, let's say, 2 comma 4 comma 5. Okay, I just love these numbers for some reason. I do not know why. So let's say the another set is 4 comma 9 comma 11. All right, if we're trying to figure out the union between these sets, it will just be 2 comma 4 comma 5 comma 9 comma 11, right? It's pretty self-explanatory. You're just putting all of the elements, you're not repeating any of the elements, you're just putting all of these elements together, right? So the elements that are in here and the elements that are in here, you're just putting them all together. You're not repeating numbers, because let's say you have 2 4s in there, you're not writing double 4s, you're just writing 1 4 and taking all the numbers here. Okay, so these are called union. Okay, union of sets, right? Corresponds to OR. Okay, you can say this corresponds to OR. It actually goes to the logic gates, but it's not going to be necessary. But if you know what logic gates are, these will be very helpful to memorize this. Okay, anyways, so you don't have to memorize this thing, just look at this thing. It's pretty self-explanatory. Just put all the elements between A and in sets A and B together. That is going to be your union of sets. Okay, so this is the notation for it. You can memorize it, but it's just it just says x belongs to A, x belongs to B. So all the elements that belongs to A are going to be part of this, all the elements that belongs to B are going to be part of this set. Okay, let's look at the interaction of sets. So it's going to be intersections, right? So intersection means, let's say we have the same set 2, 4, 5, and then we have another set 4, what did I say, 9, 11 or something like that. Anyways, so if you are trying to figure out the intersection between these two sets, it's just going to be 4. That's it. The common one is the answer. Let's say we had 2 common, right? Let's say we had 2, 4, 5, and we have B is equals to 4, 5, 12, 13 or something like that, right? So we have 2 things that are common. I'm sorry, 2 things that are common, 4 and 5. So intersection B will be 4, 5. Okay, so these are called the intersection of sets. Logic corresponds to AND. So it actually matches the description of an AND gate. 1 second. Can you guys hear me? Hello, hello, hello. Okay, you guys can hear me. So this is the mathematical rotation. So as you can see, before it was x belongs to A or x belongs to B. Now it has to be x belong to A, and it also has to belong to B. If they meet both of these conditions, then we can say this is true. If they do not, and for the previous one, if they meet any one of these conditions, it will be belong to A union of B. Okay, very simple stuff. Venn diagrams, union and intersection. So basically I have already explained the Venn diagrams a little. So refer to the Venn where only center overlapping is shaded. Where does the shaded region represent? So let's say this is the shaded region, and this is A, this is B. So the shaded region represents the intersections of A and B. This is going to be the correct one. Okay, so let's go to the disjoint sets. What does disjoint set mean? Okay, so mathematical condition, if they do not have anything in common, that means if the intersection set is an empty set, that will then these A and B will be disjoint sets. So let's say we have a set of 2, 4, 5. I love these numbers. And then let's say we have 9, 11. No joke, just a thing that came in my mind. Anyways, so these two sets do not have anything in common, any number in common. So if we do the intersection between them, the result will be an empty set. Okay, the result will be nothing. Okay, the result will be nothing, an empty set. Then we can call these two things a disjoint set. Okay, so difference set. If we're trying to figure out difference between two sets, then we can use this, or we can use this, right? If you're trying to figure this out, this difference between sets, then we can say so basically what it means, the sets elements belonging to A but not B. So let's say we have this set 2, 4, 5. Of course we're going to use that. B is 4, 9, 11, right? So if we're just doing A minus B, the set will just be 2, 4. No, so there won't be any 4. So 2, 5 will be the answer. So basically the intersection between them will not be there. So it's just A minus B. So the things that belongs to A but does not belong to B will be the answer. Okay, so we just did, we have one thing common, we just minused it. we just destroyed it. The thing in common gets destroyed. That's the definition of difference of sets. Okay, now let's look at the past CSCA question. Refer to the Venn diagram where only the part of the circle that does not touch the circle B is shaded. So this is obviously going to be A minus B. Why? So if we're were to do something like this, let's say we have this and this, right? So A minus B will be something like this, right? So it just hates B, right? It just hates B. It just only takes the part that only belongs to A. This is A, this is B. So refer to the Venn where the only part of circle A that does not touch B, that does not touch the B is shaded. That means the Venn diagram would be like this, and this is shaded. That means this is just A minus B. I hope that makes sense. If that doesn't, you can let us know. We will cover it again. Okay. Complement of sets. So complement of set is pretty easy. Basically, we know what universal set is. It is basically the summation of all sets is the mother set, right? So if we were to difference between, let's say we want to see everything, let's say we have lots of sets, right? A, B, C, D, right? And they all have a union set of U. So we are trying to figure out the complement of set A. Let's say we are trying to figure out the complement of set A. What we have to do is just U minus A, right? So this will actually just be B plus C plus D, right? Because the B, it will just be B U C U D, right? This will just be the union of the other sets that are in there, right? So it's just going to be anything but set A. Complement, what does complement mean? Anything but set A, elements of set A, right? These are called the complement of a set. So we actually denote it by like this, like a small c up there. We can also say it like this. We can say it like this. There are lots of ways to say it, but the most common I think is C. Sometimes they use this, but you get the point. So let's look at the question. Which of the Venn diagram represents A intersect B? You see there's a prime in there, right? So let's draw it. So A, U, B, right? So what does that mean? That means, let's say this is A, this is B. So all of these things are included, and we are trying to figure out, let's say this is U, right? So the shaded region will just be this. Anything but set A and B. Anything but set A and B. Diagram with background shaded, circles empty. Background is shaded, circle is empty. That's going to be our answer. Okay, so De Morgan's law. So these are the De Morgan's law. What they are saying is, if you're figuring out, if you union two different sets and then you take the complement will just be equal to the complement of A intersect complement of B. Okay, so these, and you can actually reverse the signs as well. We can say the intersect of A intersects of A and B, and if you complement the whole thing, then it will be equal to A complement union B complement. So these are the formulas of De Morgan's. These are really effective in exams. There might be questions from it, so yeah. So let's see international practice questions. So these are taken from, I think, a Chinese book. So we have some union set. We have M 1 2 3 4 5. We have N 0 3 5 7, right? So M and N, right? So what we are trying to figure out is MUN, right? MUN. So what does MUN mean, right? We can actually just do it normal way. 1 2 3 4 5 0 1 2 3 4 5 7 3 5 7 1. So it just 0 1 2 3 4 5 7 0 1 2. So I'm just figuring out the union between M and N. M and N, M and N, M and N. It's just, it sounds like M and M. Anyways, 1 2 3 4 5 7. I think that is the union between M and N. So 1 0 1 2 3 4 5 7. There's no 6. Anyways, so if we are trying to figure out the complement of it, we just have to minus it from the union set. So if we minus it from the union set, we're just gonna get 6 and 8. 6 and 8 is our answer. All right, so same goes for this. You can say, do this math at home. The answer will be 6 7. I'm joking. I did not just do that. I'm so sorry. I apologize for that. Anyways, introduction to intervals. Intervals are subsets of real number line R. Okay, so intervals are subsets of real number. They all represents all number between two endpoints. Open intervals, close intervals, half open intervals. Okay, so let's look at some examples. So what does intervals mean? So they are basically brackets. Okay, basically brackets, but they mean something. Brackets with meaning. Okay, so if they have square brackets, then the endpoints are closed. What does that mean? So let's say we have a line graph. We have 1 this is -1, this is 0, this is +1 2 3 whatever, 2 3 whatever. Let's say we have a set of -1 2 +1, -1 take a +1, right? So let's say, actually let's say we have a set of 2 -1 0 1 2. These are minus, whether -2 through +2, right? So we can say that -2 x, such as x belongs to from -2 to +2, and we put third bracket in them. Okay, so what does that mean? That means -2 and +2 are included in the set. If you were to draw the set this way, this will be -2 comma +1, sorry, -1 -1 0 1 +2, right? But if we were to say give first brackets here, right, parentheses here instead of square brackets, what will happen? This will happen. So it cannot be -2. It cannot be -2. So if we were to say something like this, +2, then the actual set will be -1 0 +1. So -2 and +2 are not included when we are doing parentheses. Basically, one corresponds to bigger than or equal, and one does not equal to bigger than or equal. It corresponds to bigger than and infinity. So when we are using an infinity sign, let's say it's from this set comes from -infinity to +2, then we'll always have to use a parentheses or a first bracket, right? So the internal notation for this is, okay, so this is going to be, as you can see, there's a bigger than or equal sign here. There's no bigger than or equal sign here, so it's just going to be -2 2 3, but there is going to be a third bracket here because there's an equal sign here. So I hope this makes sense. Wait, did I make a mistake here? I made a mistake. Did I make a mistake? Yep, I did make a mistake. So I wrote down the correct one and then I ticked the wrong one. I'm a really smart guy, as you can probably tell. Operations on interval. Union of interval, combine the coverage of both intervals on the number line. Okay, represents all the number in either interval or both. Represents all the number in either interval or both. Find the overlapping segment on number line. So union intervals, intersection of intervals. Okay, so let's look at some examples. There's no example. Combine the coverage of both intervals on the number line, represents all the numbers in either interval or both. Find the overlapping segment on the number line, represents only the numbers common in both intervals. Okay, so what does this mean? Let's see. Let's solve a question and try to figure it out. So we have a set here, we have a set here, then we have to figure out the A union B. So we can derive this set as something like -2 x, x is x, such as we can say it's also -1 0 1 2, as it says equal, right? So this is our first set, and this is the infinity set, and it goes from everything above 1, right? So let's say 0, it has to be bigger than 0, so 1 2 3 4 5, whatever, it goes to infinity, right? So we're trying to figure out the A union B, right? The union tag between them. So from -2 to through infinity. That's what should be the answer, right? From -2 to infinity. C. Yeah. So this is the correct answer. So it has to be bigger or equal to -2. Yes, it has to be bigger or equal to -2. It cannot be smaller. It from -2 it goes to infinity. So it has to be bigger or equal to -2. Okay, so let's look at this. We are calculating the intersection between these things. So it goes from -3, and then it has -2, -1, 0, 1, 2, 3, 4. This is the first set. It includes both of them, right? And then it says intersect, so from 2, 3, 4, and it goes forever, right? So we can say the intersect are the common parts, so these are the answers. So it's going to be from 2 to 4. This should be the answer. This is the answer. Okay, so let's look at this question right here. If A is -1, 3 and B is this, A intersect B is equals to what, right? So it's very simple. 1 minus 3, A intersect B, right? So let's figure out this. 1 2 1 0 1 2 3. This is the first set, right? This is the first set. And then for the second set, okay, it actually doesn't include 1 or 3, so we're just gonna remove -1 and 3, so it's just going to be 0 1 and 2. This is the first set, as its first bracket, it doesn't include them. And for the second set, it's going to be 2 3 4. It doesn't include 4, so this will be the second set, right? So as we can see, the intersection between them is just 2, so our 2 will be answer, right? Why isn't there? I think the answer is glitched. As we can see, all of them are 2 3, so the answer will just be 2 as a set. Okay, now let's move on to the next question. Practice disjoint intervals. Okay, so identify the union. Okay, we're identifying the union x such as x bigger than 0, so it's just 1 to infinity, right? And s bigger than 5, so it's 5 to infinity. actually it's 6 to infinity, right? So we're unioning them. That just means 1 to infinity and 5 to infinity. No, it's less than, x is bigger than 5. X is smaller than 0. Okay, so it's smaller than 0. So it's smaller than, so it's 0 to minus infinity. Okay, so it's 0 to minus infinity. So it's going to be from minus infinity to 0, and then it's going to be from 6 to infinity. So this is going to be our right answer. It has first bracket parenthesis right here. That means it does not include 5. So we can see that. And it also is equal to 0. So that's why it has the square bracket here. Anyways, let's look at the key formulas and recap it. So we are trying to figure out the total subsets is going to be 2 per n. The proper subset is just going to take 1 out. We're going to figure out, okay, so this is number of subsets if we're trying to figure out this number of subsets of A in union B, we have to figure out the number of subsets in A plus the number of subsets in B. Okay, so this is minus, so it's not subsets, sorry, my bad. So I don't think so they had the formula, this formula in the slide, so let me explain this formula correctly. So this is A union B. So this is the amount of elements that are in A union B, and we can figure that out by calculating the number of element in A, calculating the number of element in B, and we can minus the number of element in A intersect B. Okay, so we can also see the proper what does these things mean? Okay, so the A is a proper subset, that means A U B is A. I think they made a mistake here. Yeah, let's just move on. So this means union or intersect and difference. Difference or minus are the same thing. A minus B or A difference B, they're the same thing. Subset, we have discussed it. We only use this for sets. We only use the belongs to for numbers. Okay, so A, B are closed intervals. Okay, and we also have discussed the parentheses as well. So that was all for our set chapter. This was a very easy chapter. You're gonna get all of the questions that will come in this chapter absolutely right. Okay, best of luck in your exam. You're gonna do very well in March, and if you want the slides, it's in the WhatsApp group right there. The number is right there. There will also be a link for the group, and you can just go through there, and that's it. Thank you for everyone for sticking, for doing this class, and you will have our blessing on the March exam, and you're gonna do very well.